Hello everyone. So in this video, we are going to discuss one scenario-based question in context-free grammar and push-down automata. Okay. So this is the scenario, and grammar is given. So it is like a straightaway question. There is no scenarios given. There is an direct a set of grammars and a prediction rule is given. Now the first question is list all terminals and non-terminals in the given grammar. So in this grammar, how can you say something as a terminal or a non-terminal verb? For any grammar, you have the tuple notation as set of variable, terminal, starting symbol, and production rule. Okay, a starting symbol is usually denoted as S, or whichever is the starting variable, we are going to use that as a starting production or starting variable. And all this is called production rule. When you have one function of alpha tends to beta, this is called a production rule. And a non-terminal is or a variable is something that is usually represented in capital letter, but there is no hard rule for it. Okay, but that has a production for itself. When you take S implies something. Okay, so S is the non-terminal, whichever comes in this side. Okay, whichever comes in this left-hand side, and that has a production for itself is called a non-terminal or a variable. So you have S, NP, and norm, and you have BP, and you have DET, and you have noun, verb, and acts. So these are all the things that comes on this side, right? That has a production for itself. So this is called variables. Okay, a non-terminal is something like it here I told you now it need not to be always in capital letters. You have all small letter combinations also. So anything that has a production for itself is called a non-terminal or a variable. And set of terminal symbols, or other than this, all the remaining symbols will be a terminal symbol. You have to check in the explanation, that definition for a production. See, S tends to NP-VP. We know NP and VP are non-terminal. AUX is also a non-terminal. See, AUX is also a variable. Okay, so all your VP, DET, NOM, noun, all these things are a variable. And here you have, right, that, this, add, the. So all these things are terminal symbols, so it is not included in the variable. Okay, so these are all this terminal symbols are the one that comes in your input. Okay, so the set of terminal symbols are that, this, the, book, flight, meal, man. You have book again, include, read, and does. So, okay, these are all the set of terminals. Variables are the one that comes in the side. Only this will be a variable. Other than that, if you have any sort of productions like this also, this curly braces is also a terminal symbol. Okay, so other than that, whatever comes in this body of production, that will be your terminal symbol. So first one is done. List all terminals and non-terminals. Non-terminals are nothing but variables. Okay. And the next step is give the equivalent production rule for the given grammar. So when you want to write a production rule for these kind of grammars, it is better to go with this CFG to context-free grammar to PDA rule. Okay, so we need not to follow all those things, like assuming what all happens and draw a draw transition functions and all. So rather than that, we can go for context-free grammar to push down automata. Okay, so we have variable, terminal, starting symbol, and production for this tuple notation of context-free grammar, whereas push down automata, you have states, input, transition, element that can be pushed into stack, starting state, and set of final states. And for our example, the element that you're going to construct here is, for this usual rule of CFG to PDA construction, will be having only one state, that is Q, and your input symbols are nothing but the terminal symbols. All these terminal symbols will be your input. We have to define the transition function. And for this tau, we can push all the terminal symbol, all the variable along with z naught into stack. These are all the possible element that a stack can occupy. And we have only one state, right? That will be the starting state. And here we are going to design a push down automata for by accepting input by empty stack condition. So you don't have any final state here. So this is the tuple notation for the push down automata that we are going to define. And the only left out thing that you have to define here is del. Del is the transition function. Okay. So for del, you have three hard rules. One is for the starting symbol. For the starting symbol, Q, and when the input is nothing, without consuming any of the input symbol, if stack consists of Z naught alone, we are going to push this S into stack. This is the first rule. And second rule is for all variables. Okay, you have to write all here. I'll just write one or two. For all the variables, first when we consider this variable as S, you have to write the transition as Q without consuming any of the input symbol. If you have S in the top of stack, you can push Q epsilon. Instead of S, you can push the production for it, NPVP. So this is the first production, or you can push the second production as Q comma. I'm sorry, I don't have this. Yeah, Q comma AUX NPVP into stack, or Q comma epsilon comma S equal to Q comma VP. Okay, so whenever a variable comes on the topmost element of stack, we are going to replace that element with its production. So either this or this. So for S, you got three different production. For NP, you'll get one. For norm, you'll get two. You have to write all possible productions here. Just write the rules. Okay. And the next thing is for all terminal symbol, when it is in terminal symbol, what all the terminal symbols we have? That, this, add, the, book, flight, and all, right? So when a topmost element of stack and the input matches, that in the input and that in the topmost element of stack, we are going to pop it out both. Okay, transition of Q comma A, pop it out both. So this is for all terminal symbol. Okay, you have to write the transition for all terminal symbols. You just fill this. Okay, and the last step in this conversion is at the end, transition of Q comma epsilon comma Z naught. When you have that epsilon Z naught alone in the stack, pop it out. Since we are going to accept the input by empty stack condition, so at the end of your input, if stack consists of nothing, you can just pop it out this Z naught alone from the stack. Okay, so this is done. This is how you have to convert the equivalent rules. Okay, convert any context-free grammar to push down automata. Okay, next, you're going to derive some example. Hmm. Next question is, check if the above grammar could generate the string, does this flight include the meal? So first thing I can suggest you when you have an condition like this is, you check whether all the terminal symbols are there in your given production rule. Okay, so does is there? Yeah, it is there in X. This is there. Yeah, this is also there. Flight is there. Include is there. Uh, is there. Meal is also there. Okay, so all the given small element of terminal symbols are there in the given grammar. So now you can start with the derivation. So one thing that we can start up is we have to start with the production starting symbol S. Okay, and my first element needed is does, and does is there in AUX. So if there is any, like you'll have a multiple possibility of constructing this partial here. Okay, you don't find a simple hard rule for finding all this, what to say, tree. Okay, you'll have a multiple possibilities. You try for all those possibilities, try to take something relevant so that you can it will lead to an answers. Okay, so first I have to, the statement actually starts with this, so I need this aux starting in my starting symbol. So there is a production that has this aux, so I can just take that production, rule of aux np vp. Okay, so this derives to does. So the first element is done. Next, I want this flight include a meal. Okay, so include is a verb portion, we know it. Okay, so from this noun portion, we try to take this flight in, this flight alone. Okay, if we are able to derive this flight from this noun, then we can proceed with the remaining elements from this place. Okay, so now this noun portion, I want this function here, and this function is given in det. So when you are expanding your noun portion, you have only one possible rule for noun portion. One is det followed by norm. So this det can be tends to this, and this norm can be derived to noun, and for this noun you can give flight, noun production, and this can be given as flight. Okay, so this does this flight. So these things are done. Now we have to verify include a meal. Okay, so include the meal actually means include is a verb portion followed by something else. Okay, so for this we cannot directly take it as verb. We have verb followed by a noun phrase. So we can take this production rule as verb followed by noun phrase. I'll take another color. It is clumsy here. So for this verb, we can include it as include function, include, and so does this flight include is derived, and I just want a meal. So a is there in det and meal is there in noun portion. So I can take expand this np as det and norm, and this det can be given as a, and the norm can be expanded as noun. In this noun, you can replace noun with the function terminal symbol meal. Okay, so now the parse tree is generated. See, all your leaf nodes are a single terminal symbol. So you can just start from the leftmost leaf, combining all the leaf nodes together. So you have does this flight include a meal? So this is how you have to verify the yield of a parse tree or yield of a grammar. Okay, so we are able to derive the string. Does this flight include a meal? So it is done. Okay, good. Now this step is also done. Third question is also done. What is the next thing that you want to do? Simplify this grammar. So why you want to simplify any grammar? To convert any grammar to Chomsky normal form, we have to have the simplification step. And what all the simplification step we have? Removal of useless symbol, elimination of useless symbols. And how many useless symbols we have here? Non-generating and not reachable symbol. And second step is elimination of epsilon production. And third step is elimination of unit production. Now take the first one. We have to verify whether all the elements are generating and all the elements are reachable. How you check something as generating here? When you are drawing a parse tree, when it derives to some set of terminal symbols, it is generating. See, in the last example, we start from S and we derive to this input, right? So we can say that S is generating. And for this NP, we should have some place where on making some substitution, it stops, the parse tree stops. You have det no as a rule, and norm can be tends to noun, and this noun can be replaced with anything like man, and det is anything like a or that or anything, right? So this also somewhere somehow, like whenever you have np in the parse tree, we should have a fine way in which we are able to stop the parse tree. Okay, so this np is generating, and this norm tends to noun tends to a terminal symbol, so this is also generating. And vp tends to verb, and verb tends to either book or include or read, so that is also generating. And all the remaining symbols as a direct production. AUX tends to a terminal symbol, verb tends to a terminal symbol, noun tends to a terminal symbol. So all the elements here are generating. So you have to check all the variables whether in the production on making some substitution, it is able to derive, it is able to stop the parse tree and derives to some set of terminal symbols. Okay. So there is no non-generating symbol. Write it down. See, always when you are answering your questions, you just write the steps and mention it that there is no non-generating symbol. And for reachability, S is the starting symbol. From S, we are able to reach NP, VP, AUX. Right? NP, VP, AUX. From NP, we are able to reach DET and norm. Okay? And all the things are there. Norm is reachable, VP is reachable, TET is reachable, and a noun is called by norm, so it is also reachable, and VP calls verb. So all the symbols are reachable. See, from this S, we are able to reach NP. From this NP, we are reachable to norm. Norm, we are able to reachable to noun. Noun, we are able to reach all the symbols. Okay, from the starting symbol, all the symbols are reachable. Okay, so there is no useless symbol here. And epsilon production also, there is no epsilon, direct epsilon productions here. See, there is no epsilon here. So two steps, you can directly mention that there is no useless symbol, there is no epsilon production. And last thing is you have to check for all unit production. When can you call something as unit production here? When you have a variable tends to variable. Okay, so this is called unit production. See here, S tends to NPVP, S tends to AX NPVP. These are all some set of elements, but you have S tends to VP. So S tends to VP is a unit production. So when you have a unit production, instead of this, you have to make a substitution as wherever you have VP production, substitute it directly. So VP implies verb, or VP implies verb slash, verb NP. See, for VP, you have two possible production. And again, you have the same scenario. S tends to verb. This is also when a variable tends to variable function. So instead of verb, you just substitute the elements of verb. You can write it as S tends to book, include, read, followed by verb and NP. Okay. So this unit production is removed. So this is the final production after this unit production. I'll just cancel it out. Okay. And next you have norm tends to noun. Noun. So this is also a way where you have a variable tends to variable. So you have to replace this noun with its elements. Okay. So you have to mention it as noun tends to book slash flight slash meal slash man. Okay. So this unit production is removed, and you have BP tends to verb. So that also you have to replace it. BP tends to verb. This is a variable tends to variable. So you have to replace this verb with its production rule. That is book slash include slash read. Okay. So now you can ask me why you haven't taken this. AUX tends to does. Okay. So this does is not a terminal, not a variable. It is a terminal symbol. We are verifying for a variable tends to variable case, not this case. Okay. So this is not an unit production. Okay. So now what all we have replaced is production we have replaced. If you want, I'll write it separately here. So this is the final set of rules that we have formed after all this elimination step. Okay, elimination of non-generating, not reachable, epsilon and unit production. Now the last step is this simplification is done. This is the simplified grammar. Now the last step is convert the given context-free grammar to a Chomsky normal form. So what is this general format for Chomsky normal form? You have this, a variable tends to variable or a variable tends to single terminal symbol. So this is the only allowed format for a context-free grammar, sorry, Chomsky normal form, CNF structure. So we'll just first eliminate what all already there in the format. Okay, we don't need to redo it. See here, when you have this, all this are single terminal symbols, right? VT, norm, verb, and acts. The explanation all includes a single elements here. Verb tends to either book or include or read. AUX tends to DET. So all these things are terminal symbol. So you have a variable tends to a terminal symbols, set of terminal symbols. It is allowed. And here also, when you expand this VP, it includes book or include or read. So this is also in a standard structure. Let me just check for this VP alone once. I think I have missed one more production for VP. It is verb, noun phase. Okay, a bit complicated here. Like when you are writing it, it is better you just include all the productions and recheck it once. Okay, so these are all already there. And see here for noun, you have book, flight, meal, and man. All single terminal symbols. Paka. So here also all a variable tends to single terminal symbol is done. Now we have to check from the first. You have S tends to NP VP. So NP is a variable, VP is a variable. Okay, S tends to a variable tends to two variable is allowed. And here you have three elements. So take it down separately. This needs to be verified. So when you have a lot of productions to be checked, it is better no need to go for this renaming functions alone. Whatever is needed, you just take that alone. Okay. Now coming to this production, you have a variable tends to a terminal allowed, terminal allowed, and you have two variables. Okay, verb is a variable and NP is a variable. It is also allowed. So this production is also in the CNF structure. Now NP tends to variable. It is also allowed. And here noun tends to norm. A variable. A variable tends to two variable is allowed. This is also in general format. Like here also VP is a variable, verb is a variable, NP is a variable. A variable tends to two variable is also allowed. So all the remaining grammars are all in the standard structure. Only thing that has to be replaced is this function alone. Okay, so for this function, you can create one variable x1 that implies npvp. And you can replace this s tends to aux followed by x1. That's it. Okay, so when you are doing it, what happened here? You have a variable tends to two variable, a variable tends to two variable. This is allowed in the standard structure. Okay, so this is your CNF conversion. See, always remember when you have these kind of grammars, most of the function could have been already done. Okay, but while writing it, if there is no simplification step, just mention. When they are asking you to give a simplified grammar for this and giving a mark for it, just list out what all the steps to be implemented for the simplification, like elimination of unit, elimination of useless, elimination of epsilon production. Don't have it in your mind. Write it down. Whatever you are writing, you'll get a mark for it. Okay, and you just mentioned that there is no useless symbol, there is no epsilon production, there is no unit production. And conversion, mostly when you have a grammar like this, it would be there in the CNF structure alone. Only few modifications need to be done. Okay, make sure you are doing that modification alone and updating it. Okay, so don't complicate yourself. Try to make it much simple as possible. Okay, thank you.